All right, so we're going to do this question. It's up at the top. Basically, this question's hard because it's dealing with a 3D model. It doesn't tell you that the diagram you're going to make has to be 3D, but you're going to figure it out pretty soon after you start to draw it. So basically, I want to start to draw this as an example, and hopefully you can pick up some strategies that you can use in other 3D pictures in this trig unit. So let's read the question. Basically, there's two boats, and they're both looking at an airplane. What I'm going to do is I'm going to ignore all the stuff about stuff being up in the air. I'm just going to pretend that the plane's on the ground to start so that I can draw a triangle on the ground. Then I'll deal with the heights. So you have observer A, which is, we'll put them like right there. Let's make it black. Okay, that's A. And observer A is looking at a bearing of 48 degrees towards the plane. Okay? The way bearings work, if it's 48 degrees, you go from straight up north, and this would be 48. Observer B looks at the airplane from 285 degrees as their bearing. So let's put them like over here or something. Okay? 285 degrees would be like that. Cool. So that's 285. Now, it also tells us the bearing of observer B from A is 96 degrees. So we're going to actually have to move this from where it was. So 96 degrees means it'll be like that, and that'll be B. Let's make it more like this. Okay? That will be where B is. So basically, I'm just going to redraw what I drew before. We had the 285, so it'll be going up this way. That's 285 degrees. Sorry, and the red line I just did was 96 degrees. So let's just go over again. We had observer A looking at the plane, observer B looking at the plane. That's it. Now we have a bunch of angles. Let's try and fill in the rest of this diagram because really we care about this triangle. But we have a bunch of like exterior angles which aren't important. Now let's start with this one. If this whole thing is 96 and this part is 48, that means this part has to be 96 minus 48. It's 48 as well. Okay. I'm going to erase this because we don't really need it anymore. Cool. Now, to do this side, it's a little trickier. This was due north, and this was due north as well. So those are parallel. If I draw a line like this, going due east, I can make a right angle triangle. I can then also figure out what this angle is going to be, because I can do 180 minus 48 minus 48. Sorry, zoom in a little bit more to make it bigger. So right there, that's going to be, what, 82, 84? Degrees. Okay? So now the last part, if that's 84 degrees, this has to be 6 degrees because these three angles add up to 180 in a triangle. Now, this was 285 to do this whole big thing. That means we have, starting from here, 90 degrees, 180 degrees, 270. So that means that we have 15 degrees left to go in that spot. So this angle right here would be 9 degrees. Because these two have to add together to be 15. Last of all, we can put this angle in. We know that these three angles add up to 180, which means that this angle is going to be 123 degrees. Right, 60, 70, yeah. Cool. So now, zoom out a bit and look at the question. We have our triangle, but the problem is we don't actually have any lengths. We need to know these two lengths, or at least one of them. The question's asking what's the distance between A and B. So what we're going to do now is we're going to actually deal with the height. So let's start with this. The airplane's actually in the air. So let's draw a dotted line like this. Okay, that's the actual airplane in the air. This is just the space underneath it, like on the water or the ground or whatever below it. It says it's 10,000 meters, but the question asks for kilometers. So I'm just going to change that to 10 kilometers and then write 10 kilometers here. Okay. Now what I'm going to do is from A, you can actually look up at the airplane. And what I want you to see is that this was on the ground, this line right here. This was straight up in the air, and this was the line of sight from A to B. This is going to make a right angle triangle. The same thing's actually going to happen over here using the height that the airplane's in the air, the line of sight from B, and then the distance on the ground. So we're going to use those right angle triangles to figure out this length. I'm going to redraw this triangle, this one that we're looking at right here. I'm going to redraw it really quick underneath, just because it's easier to see. And I'm going to get too confused with all the numbers. So this was a right angle triangle, and this angle here is 70 degrees. I know it's 70 degrees because in the question it said the angle of elevation from A, which is here, to the plane, which is here, was 70 degrees. That means this is obviously 20 degrees. But I don't really need that. I also know, like I said, this is 10 kilometers high. Okay, I'm not going to write kilometers, but it's 10. So now, using just basic trig ratios, I can solve this. So I'm going to write tan 70 is equal to opposite, which is 10, over adjacent, which is, let's call this x. No, you know what? Let's call it b. That makes more sense. This is b right here, okay, over b. So when you solve for b, you just rearrange and plug it in, it's going to give you 3.63. So now, in theory, you could solve the question at this point by using sine law because you have a matching pair, and then you'd use the angle 123. For some reason, the numbers the textbook gave are off by a little bit, and basically if you do that, you'll get a different answer from the textbook. The answer ends up being like 15. That was my initial reaction to do because I like sine law better than cosine law. It's correct, it's just like the diagram and the numbers are weird and rounded, so it doesn't work. Because this is the cosine law section of the textbook, we're going to find both sides and use the embedded angle to find the opposite side. So let's do cosine law, even though it takes a little bit longer. So we just did this triangle right here, and we found this length in our diagram. Now we're going to do this triangle and find this length on the bottom. So I'm going to redraw it so I can see it a little easier. Okay, this is a right angle triangle because stuff coming up from the ground into the sky makes a right angle. This angle is actually 15 degrees because it said it was 15 degrees in the question, and this is 10 again because that's how high in the air it is. So again, I'm going to do the same thing. Okay, and this time it's going to be tan 15 equals 10 over, call this A because it's A over here. A ends up being, when you calculate it in your calculator, 37.3. So now I'm going to redraw this triangle over here just because it's kind of messy so I can see it a little better. I found this was 37.3. This was 3.63. This angle I don't know, I want to find it. We can call it P. And then this angle right here, the embedded one, was 123. So using this information, we can use cosine law. So let's scroll over a little bit, okay? Again, like I said, this triangle is this triangle right here. I just drew it on the side so I can see the numbers a little more clearly. I'm going to use cosine law. A squared plus b squared minus 2ab cos c. Remember, this is the side we're finding, which means this is the angle we need. That's why I didn't write the other two because I don't really need them. Okay? You sub your numbers in. So this is going to give me p squared is equal to 3.63 squared plus 37.3 squared minus 3.63 times 37.3 cos, and our angle C was 123. Sub that in your calculator. Don't forget to square root at the end. That's a common mistake. You end up getting 39.4, and our unit's kilometers. And that's the final answer. What I think is important to remember for this question is when you have a question where there's looking up at stuff, so there's angles of elevation, but also bearings. okay? So we had bearings, but we also had angles of elevation. It's going to be 3D. Because bearings is a two-dimensional measure of unit, of direction and stuff on your graph, your diagram. So it's going to be flat. But as soon as you throw an elevation, you know it's going up. A lot of the elevation questions you've done before has been like two people looking up at stuff standing on a flat plane. But now you got people standing like in a triangle and they're all looking up at different things. Okay, making 3D objects. You know how to work with 3D objects. Don't panic. Take your time. Do the flat part on the bottom first, then deal with the 3D shapes. And just remember that you can make right angle triangles and help yourself out. Also, try not to get confused with too detailed of a diagram. That's why I split it up into parts, but kind of had a base one that I could keep referring to so I could catch my bearings and know where I am. And that's basically it.